In the next couple of videos, we're going to write equations for parallel and perpendicular lines to a given line. So I'll give you an example real quick. I think I was graphing some with my other group earlier. Let me open this up. Here it is. Take a look at something like this. You see the red line and the blue line are parallel. So just to talk about slope first, for two lines to be parallel, they must have the same slope. Okay, I'll make something up. If I have y equals 2x plus 5, the equation looks like, the graph looks like this. I start at 0, 5, I go up 2 over 1, up 2 over 1. I'm going to graph another line that is y equals 2x. This time let's do only plus 1. Take a look at this green line. This one starts lower and at 0, 1, but it's also going up 2 over 1, up 2 over 1. So unfortunately, they're so close, they're so similar, but these two lines will never intersect. They will never meet. They just keep on going the same way, and this will happen. And if this happens, we call these two lines parallel. If slopes are the same, 2 and 2, then the lines are going to be parallel. If I change it to -2 over here and -2 over there, this time the lines are going down. But if the slopes are the same, then the lines are going to be parallel. I can make another one here. Y equals -2x plus 5. Oh, I'm sorry, plus 8. You see now we have 3 parallel lines. So remember, when the slopes are the same, the lines are going to be parallel if they have different y-intercepts. They just have different points to different different starting point or different y-intercept. They have to go through those different points. But as long as the slopes are the same, the lines are going to be parallel. There's another one called perpendicular. So let me close some of these. I'll go ahead and graph another line. Y equals positive 1 over 2x. And I'll talk about how we got that line, okay? Just a random -1 or plus 4 plus yeah, that's fine. All right, so I wish I can show you what I'm thinking here, but do you see what I mean by like the line, the red line and the black line are meeting, and what kind of angle do you think they are creating over here? I have my vaccination card on my desk. I can put my card over here and I can see they make a perfect 90-degree angle, and we call that these lines are perpendicular. Okay, they make a 90-degree angle at their intersection. Now, notice the slope though. -2 and 1/2 are different numbers. They're not the same. One is negative, the other one is positive. And also they're called what we call reciprocal, okay? So perpendicular slopes will be opposite reciprocal. I'm going to go ahead and change the numbers a little bit so that that opposite reciprocal piece is a little more clear, okay? Let me change the first equation to be, I'm going to make up y equals 2 over 3x plus 7, plus 5, okay? So that's my first equation. Let me make a perpendicular equation, okay? Perpendicular line to this. Y equals, now look, the slope is positive 2/3. So to be perpendicular, it needs to be opposite in sign. So negative, and you need to flip that fraction. Instead of 2 over 3, you're going to have to do 3 over 2x. And then I can do like plus 6. And do you notice how they meet and create it doesn't matter where they meet. It's perfect how they're meeting because both of their y-intercepts are 5. But if I change it to 4, I want you to pay attention to the angle these two lines are creating at their intersection. So if they are meeting and they're making a 90-degree angle, then we say these lines are perpendicular. And to create perpendicular lines, we need to make their slopes opposite in sign. One needs to be positive, the other needs to be negative, and a reciprocal. So reciprocal means just flip the fraction. And I think I want to kind of give you a little more review on opposite reciprocal. So let me add a page here because I want to give you some examples here, okay? So suppose that the slope, the original slope is m equals 2/3, okay? the original slope is 2/3, the parallel line will have a slope of 2/3. It's going to be the same because they have to go up the same amount, go to the right the same amount, so that they never meet. The perpendicular slope though, and look at the notations, guys, the symbols that I'm using, upside down capital T, looks like a 90-degree angle there, right? That means perpendicular slope. You have to make the number negative because the original was positive, and you have to flip the fraction. So no more 2/3, you're going to make it 3/2. So the first practice that we're going to do is we're just really going to focus on these slopes, writing slopes. So that's one set. Let me give you 2 more sets, okay? How about I say m is equal to -1/7. Okay, the original slope is equal to -1/7. What will be the parallel slope? The parallel line will have a slope of -1/7. It will be the same. Okay, it's going to always be the same as the original. Okay, but perpendicular slope, it has to have an opposite sign. So opposite of negative is positive, right? So the sign will be positive, and we need to make it reciprocal. We have to flip that fraction. So if you flip 1/7, that will be 7/1. But we don't really write it like that, right? Plus 7/1, that is the same as what number? Just 7. So that was another example of set of slopes, parallel slope, perpendicular slope. Let me give you one more set, okay? How about if you have the original slope of -5, okay? Well, we all know that the parallel line will also have that same slope of -5, okay? But what about the perpendicular? What about the perpendicular? Remember, it needs to have opposite, reciprocal, right? So we know the sign has to be positive, but how do I flip the fraction? It's not even a fraction. So how about we write this in fraction together? You can make any number into a fraction by putting 1 over it, okay? -5 is same as -5 divided by 1, right? Now we can flip this. If you flip it, you will get 1/5. So the perpendicular slope is simply 1/5, okay? So hint, if you get a slope that is not a fraction, don't worry, make it into a fraction by just putting 1 over it. And then flip it if you want to find the perpendicular slope. I always say that parallel lines have same slope. Let me bring it up. Lines have the same slope. Oh, I don't know if I need to put the word though. I'll just say same slopes. While perpendicular line, they're a little different, right? Perpendicular lines have opposite in sign and reciprocal slopes. Our textbook did it a little bit differently though. They did say that perpendicular lines will have slopes. So when you multiply those two slopes, they give you -1. Okay, they did it that way. Let me read that for you. Okay, they said 2 non-vertical lines are perpendicular if and only if the product of their slope is -1. Let's see if that is true, okay? Over here, if I multiply the original slope of 2/3 times the perpendicular slope of -3/2, what will I get? Well, look, 2 cancels out, 3 cancels out. Only thing that's left is negative, which means it's -1. So they do multiply and give you -1. So let me check the next one. If I multiply the original slope of -1/7, -1/7 times the perpendicular slope of 7, the 7 on top and 7 in the bottom cancel out, leaving me with just -1. So yes, we can check the last one too. But perpendicular lines, I mean, I always teach it as just they have the opposite reciprocal slopes. But if you have those slopes, you can check if they multiply to give you a slope, the product of -1. So that's a little introduction to slopes of parallel and perpendicular line. And in your notes, you're going to have a nice table organizing what we just talked about, okay? All right, let's see how long I've been going. About 10 minutes. I think this is a good point for me to stop. And in the next video, I will come back and talk about goal number 3, example A, B, and C. Hold on, A, B, C, and D. That's going to be a slightly longer one.